First thing to know is that India is in the northern hemisphere. This is the 0 degree latitude and we are here. We are here, right? We are at 8 degree. Our latitude starts at 8 degree. So this Tropic of Cancer goes almost in between us. Tropic of Capricorn is here. So the earth is moving around the sun. When the earth is moving around the sun, if you see that the movement will cause for a year, it will cause the different seasons like this. If you are here, it will be winter. If you are here at spring. So whenever you are here, then you have to see where India lies, at which position. So this movement also gives rise to different seasons. Now, because earth is moving and we are not like this. The axis is not like this, right? The axis is tilted. Some degree it is tilted. So when it is tilted, if you see that the sun rays are coming like this. So the sun rays are falling exactly on this region. But this region is changing. That is, we always think that the equator will have a direct, will be the, you can say, have the warmest place. But it is not that. Because of the inclination, the solar energy, see, we are here. The solar energy, or you can say the heat of the sun, will not reach at us in the way we think about this manner, because the earth is tilted. So what happens to this place? We have a concept called ITCZ. And this ITCZ, because the earth is tilted and it is moving also on its axis and it is moving around the sun also. So what happens when you have sun here and the sun rays are directly, this is called Lambavat. It is directly falling here. It is directly falling here. So this place will become quite hot. When this place will become quite hot, this is called the ITCZ place. Whichever place, because of the direct sunlight, this place is called ITCZ. We'll talk about this ITCZ. Now this ITCZ, because the earth is tilted and it revolves around also, so this place which gets very, very, very hot, whenever you say boil water, what will happen? The water will boil and it will go up. It will move up. So always when the place is heated, the heat will go up. When the heat will go up, there will be a low pressure area here. So there will be a low pressure area here at the equator when the sun rays are directly on this place. So the air, because wind always flow from the high pressure area to low pressure area. So because of this high heat of the sun, this place, because the air have already gone, the warm air, this place is low pressure area. So this place is low pressure area. So the winds from here, they goes like that. They reach here. They reach here. These are called trade winds. So the winds are going like this and the winds are coming like this. See, means if this is the equator, the winds are coming like this and these winds are going like this. Means these winds are just coming because they have to fill this low pressure area because they are at high pressure area. Now, this ITCZ is not fixed. It is changing. It is going like this, it is going like this. So this pressure area changes. So when the pressure area is at this place, the air will go flow here. But when this ITCZ shifts, as you see here, it is shifting. So when it is shifting, these trade winds will move like this. But there is a Coriolis law. The Coriolis law say whenever the trade winds, they change the pole. This is northern pole, this is southern pole. They change their direction. So these winds which are coming here, when they go up, they change their direction. They change their direction because here we have the ITCZ. This is moving from equator up and down. So we have this ITCZ changing, and therefore these trade winds are also changing because of the pressure areas. So we have to see at which place which region is getting hotter. Whichever place is getting hotter, it will create a low pressure area and all the winds will start flowing that. And this is the phenomena, and this is the idea of monsoon. What happens in Indian monsoon is there is a high pressure area here. High pressure area is here, and the trade winds, they have wanted to cover this ITCZ, but when they reach here, after crossing this, because of this high pressure region, they actually start flowing like this and flowing like this, and this is nothing but the monsoon. This is your southwest monsoon from Arabian side, and this is your monsoon from the Bay of Bengal side. So this is how monsoon reaches, and because it is flowing on the water or it is gaining the moisture, therefore India gets the monsoon. So this is the whole idea of the monsoon, ITCZ and trade winds, and of course the movement of the earth like this. So this is Indian monsoon. Monsoon are nothing but seasonal winds, and they reverse their direction of flow with the change of season. The climate of India is strongly influenced by the monsoon winds. So what are the factors that affect the mechanism of Indian monsoon? First is the differential heating and cooling of land and water create low pressure on land while the sea experiences the high pressure. That means that whenever we have the land area says this region, Tibetan Plateau. So this region land area, it heats up quite well, and it heats quite early, and also it takes no time to cool down. While this sea area, they take a lot of time to get warm and also a lot of time to get colder. And if there is differential heating, that means if this Tibetan Plateau is quite hot, and this area, say this region, is quite not that much hot at this one, so there will be a differential, there is a difference in the temperature, and because of the temperature, because of various other aspects, the air will start moving, and that is how the monsoon comes, because monsoon is nothing but the moving winds. Then shifting of ITCZ, we have discussed about this, intertropical convergence zone, ITCZ, over the Ganga plain during summers. So the ITCZ, because normally the equator is here, so there is a direct sunlight, but because of the tilt in our axis, this ITCZ reaches here, sometime here, sometime here. So when it reaches here, this is the place where we have the lot of heat. Mostly the sun rays are directly here. So this becomes quite hot. Because of becoming hot, there is a differential temperature between this area and this region. The intensity and position of high pressure area towards the east of Madagascar, approximately at 20 degrees centigrade. So we have this 20 degree latitude. So we have this Madagascar area, and here we have this region. So this is around 20, this is 0, 30, so this 20. So this is the latitude which we are talking about. So the intensity and position of high pressure area, so we have a high pressure area towards the east of the Madagascar, approximately at 20 degree over the Indian Ocean, affects the Indian monsoon. This affects the Indian monsoons because this is now the high pressure area. This, because ITCZ is there, so it is highly heated. This Tibetan Plateau is highly heated. The warm air have already gone up. So now this is a region of low pressure. So this high pressure region, this low pressure region, now the air has to flow from here to here. And these are the westerly winds. When these westerly winds, or you can say the trade winds, sorry, not westerly winds, these are the trade winds. Westerly winds are here, this one. These are the trade winds. So when they trade winds, they crosses the northern, means the equator. So in the northern hemisphere, they are also pointed towards this low pressure area. So the heating up of this Tibetan Plateau, this region, in summers creates a low pressure area about this plateau. So we have a low pressure area here. So the movement of the westerly jet streams, that is these westerly jet streams to the north of the Himalayas, and the presence of the tropical easterly jet stream over the Indian peninsula here during the summer. See, this is the stream we are talking about. These are the tropical easterly jet stream over the Indian peninsula during the summer. So there is a southern oscillation. That means now these winds, these trade winds have gone up, and because of this high pressure area, the wind start blowing here, like this. So on the onset of the monsoon and withdrawal, that is how the monsoon enters India and how it is leaving India. So the duration of monsoon is around 100 to 120 days. From early June, that is from 1st June it starts normally, to mid-September, that is around 100 to 120 days. And when the monsoon arrives, the normal rainfall increases suddenly, and this continues constantly for several days. And this is known as the burst of the monsoon. So when this is north, south, east and west. So when this southwest monsoon or southwest winds, they reaches this Indian region, there is a burst of the monsoon. That is, the rainfall increases rapidly. So it proceeds in two directions. That is, in this one direction, which is the Arabian Sea direction, and the other is the Bay of Bengal direction. This is the Bay of Bengal direction, or you can say branch. So this Arabian Sea branch reaches Mumbai here after 10 days. That is around 10th June it reaches here. The Bay of Bengal branch also advances rapidly in this direction. It arrives at this place, that is the Assam, in the first week of the June. And the withdrawal, this is how it reaches. The withdrawal of the monsoon begins in the northwestern. This is north, this is west. So it starts from here. So this is northwestern states of India. By early September and by mid-October, this monsoon withdraws itself completely from the northern half of the peninsula. This is the peninsula region. So northern half, it comes out by mid-October.